Here we have another frame problem. So we're given this three-member frame that is supported at A and at B by a roller and a pin. Now we're getting a distributed load on member CD. And what are we asked to do? We're asked to find the forces acting on the pins in E and on C. Include all of our free body diagrams and so forth. All right. So we're not asked for everything. We're just asked for these two. And then there's a hint. Make sure to choose your solution strategy before solving equations. You only need 4 equations to solve this problem. All right. So we'll have to think a little bit before we start. We have 4 unknowns and we only need 4 equations. So we can solve all of them directly. Let's see. We'll definitely need this horizontal one, right? Because that's the only one that has a load on it and has both E and C in them. So pretty sure we'll need that one. So let's draw a free body diagram for that one. More or less straight line. We will have our support reactions at E and at C, or like our pin reactions, I should say. All right, so we can say there's going to be an EX and an EY, and then there's going to be at the end here, there's going to be a CY and a CX. Now these all look not at all like letters. Let's try this again. CY and CX. There, looks a little bit better. Quick setup here, X and Y. Now, what else will we have? Well, we have our load. What is our load? It's a triangle, so we can say R is equal to 1/2 times 200 Newton per meter times the length is 6 meters. That would be, let's see, should be 600, right? 200 divided by 2 is 100, 600 Newton. And of course we know our X bar is going to be 2/3 times 6 meters. That is 4 meters. Four meters from D, or 2 meters from A, depending on how we want to see this. All right, so we know it's going to be somewhere here, like this maybe. R equal 600 Newton, and this distance, X bar, is equal to 4 meters. All right, so we know we have this one, but this is of course not going to give us all 4 because we have only 3 equations, but we can certainly get EY and CY from this one, and then nothing else much. All right, so let's see what else we have. Let's just sketch. But let's give this a number 1 because we're definitely going to use this one. Now, if we choose the other long one here, the sloped one, let's see, what do we get? If we get the sloped one, we would get a, down here we get support reactions, so we'd get BX and BY. We'd get BX and BY, not interested in them though. We would get CX and CY. Let's make sure we draw them the right direction, right? This was up, so it has to be down. CY, that was to the left, that was to the right, so this one has to be the left. CX, and then we get that other pin up here, which would be, let's make them in the same direction here maybe, would be DY and DX, yeah. So remember, we had 2 equations we used up here already, so we only have 2 equations left to get to get cx and ex. So can we use one equation to get cx here? Do sum of forces, we have multiple unknowns in the x direction. If we do sum of moments, we'll have multiple. Yeah, so this one's not going to help us. Let's see about the other one. Or we have to figure out what the strategy is. Let's do the other free body diagrams. That was the straight one down. So what do we have? We have the support reaction at the bottom. That'd be A, going upward. We would have EX and EY. Let's make sure they counteract. So EX in this direction and EY upward, because it was downward there. And then we'd have dx and dy. So dx was to the left here, so it would have to be to the right here. Dx, and that should have to be going upward for dy. Now, can we get dy and can we get ex? Yeah, we can get ex. This is the one. Oop, not in blue. Right, this is the correct one. Because we can do a moment around D, and then we can get EX. So let's do from 2. We can do sum of moments around D equal to 0. Now A goes straight through, line of action goes straight through, right? It was like the straight the vertical bar here. So that's the case. EY goes also straight to EX, does have 0, so all we have is EX. EX is turning counterclockwise, so we'd have EX times whatever that distance is, doesn't really matter. 6 meters, because it's just going to be 0 anyway. Times 6 meters, that means EX equal to 0. That's always good. Now, if we have EX is equal to 0, then we know that CX will have to be 0. So also from 2, we have sum of forces in the x direction is equal to 0. That means minus EX plus CX. Minus EX plus CX. Right, that was the right minus EX. All right, trying to get CX. Means CX is equal to EX equal to 0. All right, we have to. Of course, we could go back to 2 and get what dx is, but we're not asked what dx, right? We're only asked for E and C if we go back here, right? E and C. So we have EX and we have CX, so now we can do the moments, right? So we can do a moment around E and moment around C, and that should give us all that we're looking for. So we can say from 1, oop, this is not 2, this is 1, all right? Hope that didn't confuse people too much. And from 1, right? From this free body diagram, there's no CX in 2. All right, so again from 1, we can do sum of moments around E equal to 0. And what do we get? If we do sum of moments around E, we'll get R. This distance is 4 meters, that's the rest is 2 meters. So that is 2 meters going counterclockwise, so 600 Newton times 2 meters. 600 Newton times 2 meters. And what else? CX, line of action goes through E, so only CY. CY is 6 meters from there. And it is turning also counterclockwise. So plus CY times 6 meters. That means CY is equal to, is that correct? CY is going counterclockwise. And yeah, both in the same direction. All right, so that means CY is minus 600 Newton times 2 meters divided by 6 meters. So that would be minus 200 Newton. Would be CY. Minus 200 newtons. All right, if that is the case, then, well, let's do the second moment as well. All right, we could do sum of forces, but let's do sum of moments around C is equal to 0. That would give us EY, because EX doesn't have a moment arm. So we'll start with R. R is turning counterclockwise, and it is now 6 plus 6, 12, 14 meters. So 600 times 14 meters. And then EY is also turning counterclockwise. All right, they're both turning the same direction now. Plus EY times EY times, what was that distance? 14 meters? No, 12 meters. 12 meters? No, 6 meters. From C to E. Yeah, 6 meters. Times 6 meters. That means EY would be minus 100, 1,400 Newton would be EY, right? Negative sign, 100, yeah. Does that make sense? CY was negative, so upward. So going downward. Yeah, I think that makes. So we didn't do sum of forces in the y direction, right? So let's do that as a test, just to make sure. From 1, sum of forces in the y direction equals 0. It's equal to what? We get R plus EY minus CY. R plus EY minus CY, correct? EY minus, no, in the y direction we're saying, right? Y is minus R minus EY. Why am I doing this all backward? Minus R minus EY and plus CY. There we go. This is how it's supposed to be. So that's minus 600 Newton. EY is minus, minus is plus, so plus 1,400 Newton. CY was negative. That does not look correct, I'm sorry to say. Okay, where did we go wrong? Right, this would be 800 and 1,400. Where did we go wrong? So one of these signs did not work out. Let's go back to sum of forces around E. So we have 600 going counterclockwise, and we get CY going counterclockwise. Both positive. If they're both positive, this should be negative. All right. Then if I go to C, then they're also both positive. Also both positive. 600. We did 600 times 14. That'd be 600 times 8. There's my problem. There is the problemo. This is not 14 meters. Alright, this is 2 meters here and 6 meters. I was thinking about the 12 meters of the entire thing. Alright, so this would be 8 meters instead. Let's double check that, not do the same mistake again. Right, 6 plus 2 is 8. There we go. So that means if we divide by 6, so we have 800. So this is minus 800. Minus 800 Newton. Alright, so if that's minus 800, then we get minus 800 down, get plus 800 here. This is minus and minus. And 600 and 200 is 800. Alright, so now we have it correct. Very good. Alright, so here we had this big frame, but we're only looking for the forces in E and C. So just like the hint said, we were able to do this smartly and get just use 4 equations. Well, in our case, we used 5 equations because we did the little test that showed us that we were incorrect, but we were able to fix that mistake. And of course, we could get all the other forces as well, right? So if we'd have EX, we have DX, we have EY and DY. We get A, all those kind of things, like one after the other if we wanted to, but here we're only asked for E and for C.